Before I introduce our distinguished speaker today, I would just like to take a few minutes to tell you something about the colloquium itself. The colloquium itself was started about 2 years ago, primarily with the group of public education. Even in this northern campus, we know that all of us are experts in some little thing, but we are laypersons in many other things. So that we can improve our own literacy about California's water, we thought of this particular colloquium as part of the Water Resources Center archives. And it is organized in such a way that we try to attract speakers from a broad spectrum of knowledge from the humanities and the sciences about water. Obviously, such a colloquium cannot succeed without the help of a few people. So the way this colloquium is organized, we have a little organizing committee consisting of faculty members from around the campus. We collectively try to identify interesting topics, identify new speakers, and then go after inviting. So the committee consists of Professor Joseph Sachs from law, Professor Matt Condall from environmental planning, who is a geomorphologist, Michael Hanneman from agricultural resource economics, David Sedlak from civil engineering, myself, I have a joint appointment in material science and engineering and environmental science policy and management. We have a graduate student, Randolph Clay, who gives us perspective from the student point of view. And finally, we have Linda here, Director of the Water Resources Center Archives, who takes care of all the administrative details. And clearly, we need some money so that we can treat our distinguished speakers with some amount of courtesy and decency. And for that money, for the last 2 years, we have had financial support from several deans across the campus. The Dean of College of Engineering, Natural Resources, both Hall School of Law, Letters and Science, and the Metropolitan Water District of California. So with this financial support is only one part of it. The fact that all these 4 or 5 deans can come together to support a venture that is based on knowledge itself is not a good thing, because water unites all parts of this campus. And when we started this colloquium series 2 years ago, we just wanted to give it a trial run for 2 years. We were at a sort of self-imposed probation. We were not quite sure how it would go. Fortunately for us, this seems to have gone on successfully. They have had good audience, and the speakers have been excellent. They have been enthusiastic. So we decided to continue this, and I'm very pleased to inform you that all these deans have agreed to support this venture indefinitely into the future. In addition, we have 2 more supporters. One is the Dean of the Landscape Architecture School, and the other is our Provost and Vice Chancellor, Paul Gray, has also joined in with some support. So we will continue this next year, and we are already planning for a good set of speakers. And one little, when you try to arrange a colloquium like this, there are a lot of little things to be taken care of. One is a place. We are very fortunate to get this place, but when we wanted to go and have this place again for the fall, we have had some problem. So it looks like we have to change the room. We are still trying to find a good room on this side of the campus for the fall. And please watch out for the emails and brochures to learn about that in the next series of talks will be. And finally, one more announcement before I introduce the speaker. Here is a little sign-up sheet. Please, all of you sign your names on this. And there is a last column. This is optional with your email address. So if you want the information to be sent to you, please provide your email address. With that, now I come to introducing our speaker for today. in the scheme of things that we have set ourselves, today's talk is in the area of
do it there.
And in relation to water, what more is more engineering than dams? Dams hold a remarkably fascinating place in the scheme of things. They're awesome. They summarize some of the most creative engineering feats of modern times. And they also have other consequences. And today, to speak about dams and water resources, we have a very distinguished engineer who has spent almost 50 years in this business of engineering related to water. Dr. John Cassidy has had a very long career in civil engineering and hydraulic engineering, especially both with the university system as well as with the industry. He got his civil engineering degrees initially in Montana State University, and then at the University of Iowa, where he studied under a very famous civil engineer, Hunter Rouse. And then for some time, he taught at the University of Missouri at Columbia. Then he joined Bechtel, where he had a very long, very distinguished career as a chief hydraulic engineer and then as a manager. And in between, he took a break and spent some time at the Washington State University at Pullman, where he was the director of the Water Resources Center. By the way, our Water Resources Center archives is part of the Water Resources Center of the University of California. His long experience has involved irrigation projects, hydroelectric projects, nuclear power projects, and many other projects in which water and hydraulics have played an important part. And here he is going to summarize for us from his vast experience in layman's language this thing about dams and how they are related to water resources, not in a very simple way of just delivering liters of gallons of water from point A to point B. There is much more to it than that. And today, Mr. John Cassidy is going to talk about that. I'll take it.
Thank you, Professor Narasimhan. He dwelt on a number of things I've done, and that reminded me I changed jobs quite often. My mother always wondered, why can't you hold a job? But I have truly enjoyed working in water resources, and I had the opportunity to be working with dams a lot of the time. Not as a dam designer, but more as a hydrologic engineer determining what the output of dams would be, and as a hydraulic engineer designing those aspects of the dams. So it's been a long road and one that I've enjoyed greatly. How do I get this thing to go back?
The back arrow, you're all good.
You're right. Here we are. So it's a real privilege for me to be here, and a little bit frightening for me too, because I don't know who's sitting out in the audience there, and I'm sure you can find plenty of questions to ask that I can't answer. But I thought I'd go back just a little bit and talk about, first of all, about history very briefly. The first dams were constructed about 8,000 years ago in Mesopotamia, as far as what history we have indicates. And certainly they were irrigation dams at the time. Dams were also built for irrigation in Jordan and in Egypt in about 1100 BC. And there is a project in China, the Dujiang irrigation project, which actually still exists, and started in 300 BC, and at that time irrigated about 800,000 hectares. In large dams, and according to the International Commission of Large Dams criteria, a large dam would be defined as one that is more than 15 meters high. In 1949, only about 5,000 existed, had been constructed at that time. By 2000, there were 45,000 dams on Earth. So about 40,000 were constructed in that interim period of about 51 years. So they were going very rapidly, one a day or more than that in general. The benefits that dams have achieved are manifold. And in general, those of us who worked in that area like to believe that the benefits were easily recognized and were certainly well worth the effort that's spent. We'll talk about that just a little bit later in more detail. But benefits have been for the very large part, irrigation projects all over the world, some of the largest of all in India and Pakistan and in the United States as well. Electrical energy is certainly one of the major benefits, particularly in developing countries where energy is in such critical need and just not available. In the U.S., hydroelectric power, along about the end of the 40s and beginning of the 50s, began to be somewhat in disfavor because it was looked on as peaking power, and peaking power wasn't considered to be very valuable at that time. The situation has just changed now. We have large base load power with nuclear plants and other thermal plants, and peaking power has become the most valuable resource, and as such then hydroelectric plants have in themselves become real cash cows when they're operated correctly. Municipal water supply, an obvious thing for most dams, and supplemental navigation downstream. The dams on the Missouri River are certainly classic examples of where a major benefit has been to supplement navigation on the lower Mississippi and lower Missouri rivers. Flood control probably was the second most important aspect of the design and construction of dams. And particularly here in the United States, a great many dams have been built with the major element as flood control. Now, for a long time, recreation was not considered an economic benefit. And it was back in the 50s when the argument began to rage that you could justify building a dam and include recreation benefits. And the federal government finally was able to achieve that through Congress back in the 50s, so that a multi-purpose dam could be justified on the basis of economics, considering power generation, navigation, irrigation, and recreation as well. Many different types of dams, and some that I'm going to show you here I'm sure are ones that you've never seen. I deliberately picked dams that wouldn't be familiar to everyone. I was traveling in Peru a long time ago, and this is a tailings dam. Tailings dams are probably as common as anything else throughout the world, and they're also the ones that tend to be the most hazardous because they usually contain a lot of heavy metals behind them, and often chemicals that when released are harmful. This I thought was a very interesting one. It's just about 800 feet tall, 250 meters or so, and you can see it's been stepped up from the downstream side. It's manufactured totally with tailings, and you'll also note that there's no spillway on it. So these are not uncommon in South America. This is strictly a power dam. Bechtel designed and built this some years ago on the Cowlitz River in southwestern Washington. It's a unique design in that you don't see the powerhouse. The generators and turbines are contained within the dam. There are hatches in the spillway surfaces that allow you to remove and place turbines and generators through them. But except for the switch yard, it doesn't look like a power dam at all. Yet has been at this point very successful and economically strong generator. This, in general purpose dams, this is one that has a great deal of purpose. This is Kariba Dam in Zimbabwe. Had a lot of technical difficulties with this for a long time because of erosion in the pool downstream from the spillway, and you may have seen a lot of classical papers related to this. It has a huge reservoir behind it. Generates a lot of energy in a country where there is very little energy to be had. It's in Zimbabwe, and Zimbabwe has all kinds of strife going right now, and I'm not sure just what's happening with Kariba Dam. They've also had a tremendous change here environmentally, because the reservoir itself, when it's filled, the fish population in the reservoir totally changed from what they had previously, and somebody planted sardines in it, and now they harvest sardines in great quantities out of Kariba Dam in fresh water. I'm not sure anybody even realized that they would flourish in that, but they do. Another type of dam, strictly flood control. This is the one that crosses the waterway in Holland and prevents storm surges and water from flooding the fields of Holland. And it is strictly flood control in every sense, but here's a case where the environment was drastically changed as a result of this dam, from a seashore environment to an agricultural one of significant beauty, but has never been considered to be negative. It's always been positive in every sense. This is Three Gorges Dam. It's so big, this is the best picture I could put together of it. It's an artist's rendition. I've been over there a couple of times. A tremendous amount of disagreement as to whether this dam should have ever been built. It'll displace about over 1 million people. Perhaps as a result of all of the demonstrations and agitation, the Chinese have been working very, very hard to take care of the people that are being displaced. They are building new housing upstream rapidly, much better housing than the people have lived in before. And they also have significant training programs going, hoping that they can attract somewhere in a neighborhood of 100 to 200,000 of these people to leave an agrarian lifestyle and move to Shanghai and work in their technical industries where they need people. They have more people here than they will need once the dam is completed. But in Shanghai, they have very big needs of technical people. The dam right now is, I'd say about a half complete or so. They have diverted, and the left side of the dam is, the concrete portion of it is nearly finished. The lock structures, there are 2 lock systems, 5 locks in each of these systems to lock major vessels upstream and downstream. And there's also a ship lift or a ship elevator that handles smaller ships. Their chief reason for building this is flood control on the lower Yangtze, and to provide enhanced navigation to Chongqing upstream. Currently, the water gets low enough during the summer that only very small boats can make it all the way to Chongqing, and so they, which is the heart of another industrial part of their country. This is Folsom Dam. You may recognize this. There's 2 pieces there. Back in July 1995, one of the gate number 3, a very large Tainer gate, failed on this when they were starting to open it. And it created quite a concern about dam safety within California. Dam safety had been a major issue in California anyway, but this began to make agencies, particularly Department of Water Resources, dam safety people, concerned about whether gates in all of the other dams that had this type of gates might be a problem. Folsom has another unique problem in that it really can only pass about a 500-year flood without being overtopped, which is a very small flood for a major dam like Folsom with several million people living in the floodplain downstream. And they are currently, the Corps of Engineers is currently trying to come up with schemes to increase the capacity, flood handling capacity of this dam. One of them you're familiar with, I'm sure, is building Auburn Dam upstream, which was killed many years ago, a Bureau reclamation intention. Whether Auburn will ever be built or not, I'm not sure. It's been being studied, and every year it comes up. But currently the Corps is looking at all the upstream dams that exist and trying to talk dam owners into allowing them to fund a increase in storage capacity for flood control. If they can get all of the owners to do that, they can actually increase the capacity of Folsom, they believe, to where it would pass the probable maximum flood without serious danger. Negative impacts of dams have been very much in the forefront for the last 10 years particularly, but even before that, 15 years. The major problem being that lands are inundated. Every time you build a dam and flood the reservoir, you displace people, and as I mentioned, in Three Gorges, they're going to displace about 1 million. It changes the river regime entirely. The downstream conditions are altered. Sediment is not passed downstream in the same way it was previously, and the peak flows are not the same. So there are lots of arguments now that perhaps environmentally the river regime ought to be retained to the degree that you possibly can. That's been a big issue on the Columbia River for some time now. It changes the habitat in the reservoir drastically. As I mentioned, Kariba, we're a totally different fish population. It also changes the fish habitat downstream. For example, in the Midwest, dams constructed there are usually on waters that were warm and heavy bass populations in them. With the high dams now, such as Table Rock in southwest Missouri, you have very cold water coming out of the dam, and so the fish population has switched from bass to trout. All the trout fishermen think that's a very good deal. The bass fishermen are not so sure. The biggest concern seems to be that in many cases the predicted benefits were not realized. And for particularly a lot of dams in foreign countries, the owners and the developers and the engineers have been accused of the dam never meeting what it was achieved. As a result of all of these negative concerns, a World Commission on Dams was convened back in 1998. I was quite active in the International Commission on Large Dams for many years, and for about 5 or 6 years running, we would have active demonstrations at every one of our meetings by anti-dams people, the Friends of the Rivers, American Friends of the Rivers, and various other international organizations. The criticism was not directed only at dams. We felt it very much there, but criticism is leveled at a lot of other things, and I'll touch on that briefly just a little bit later. But this the World Commission on Dams is an international commission. It was funded by some 53 corporations and agencies. And foreign governments as well put some money into this. They were charged to make a rigorous, independent global review of dams and what had actually happened to dams that had been constructed and what were the actual impacts and how important were they. The opposition to dam building points up here is old. There are records in medieval England where boat owners objected violently to people who built mills and put diversion dams across the river divert water to power their mills. 17th century Scotland, some fishermen destroyed a mill owner's dam because it cut off the path for the salmon to get upstream. In 1900 in California, many of you may remember John, or have read about, that John Muir bitterly opposed the construction of Hetch Hetchy Dam because it flooded a very beautiful canyon within Yosemite National Park. That was bitterly fought, and the federal government finally went against John Muir and allowed the city of San Francisco to build it. The city of San Francisco felt that they really had no choice. They needed a firm supply of high quality water, and that was one place where they could get it. Now, the modern opposition to dams is based primarily on social and environmental concerns. What happened to the people who were displaced by the dam? Did they receive any benefit as a result of that dam being constructed? And what was their life like after the dam was constructed, as well as environmental concerns? We've mentioned that downstream river regime changes and the habitat within the reservoir changes drastically as well. Worldwide demonstrations have occurred. There have been big demonstrations on the Narmada River against the high dam, Narmada Dam, demonstrations on the Narmada River against another dam further upstream whose name escapes me right now. And as a result of all of these, the World Bank began to change its policies and procedures. The World Bank has for a long time been the primary funder of water resource projects around the world. International Monetary Fund and the World Bank also fund other things. They fund natural resource projects, including mines. They fund infrastructure projects, including urban types of things. And there have been objections to some of those things, not just dams. Recent opposition to World Bank projects that were proposed. There were 12 dams that were singled out as being opposed. Three Gorges was one of those. There were a couple of in Indonesia, the Narmada Dam in India. There were 14 forest and natural resource projects where they were going to reforest large areas and harvest natural resources. There were 5 mines and industrial projects that the opposition felt were not being evaluated correctly, and if evaluated correctly, should not be funded. And there were 2 urban infrastructure projects. One of these was in Indonesia. I'm not sure where the other one was. The central issues that the World Commission on Dams found in their studies were costs and benefits. Dams simply had not produced the benefits that they thought they were going to produce or were projected to produce, and there were serious cost overruns. In many cases, the cost overruns were 50 to 100%, and in one case even 189% of the original cost. I'm sorry, I need... The environmental impacts have always been a major issue. Social impacts and equity, who shared in the benefits of what was going on, and were the economics actually achieved? Did the project pay for itself in the end? And finally, governance and participation. Who governed the project? Who had voices in what was being done and how it was operated? And finally, the opposition maintained that in many, many cases, alternatives were not studied. For example, if a dam was being built for hydropower primarily, why didn't they study wind turbines? Other situations, other things like that, if it was irrigation, they could have looked at some other means of as well. The World Commission on Dams decided to make 7 detailed studies of large existing projects in the world. First one is Grand Coulee in the U.S., then Tucuruí in Brazil, which is in the northern part of Brazil. Aslantas in Turkey, a large irrigation development along the Euphrates River. Glomma and Loddon Basin in Norway, big hydro development scheme. Tarbella in Pakistan, Pakmun in Thailand, Kariba in Zimbabwe. We talked a little bit about Kariba. Grand Coulee was built back in the early 30s. And one of the things that was brought out there is that the Yakima Indian Nation was displaced but was never consulted at all as to whether they felt this project was necessary or desirable, and certainly never shared in any of the benefits. Grand Coulee is one that has paid out a long time ago. It generates enormous amounts of electricity. We benefit from it down here in California, since we have an intertide of the Northwest, and our utility companies here purchase a great deal of energy from the Northwest as a result of that. Tarbella has major problems. Some of you may realize major problems are that sediment is rapidly filling that reservoir, and a major wedge of sediment is moving downstream at the rate of several kilometers a year. And there appears to be no way that this can be stopped or mitigated. It's a very serious problem. Tarbella was one that overran estimated cost by a good deal more than 100%. Now, the conclusions the World Commission on Dams made, and I'll just read these, and then afterwards I'll give you a few of my own personal opinions. The first conclusion was that in too many cases, an unacceptable and often unnecessary price has been paid to secure those benefits, especially in social and environmental terms, by people displaced, by communities downstream, by taxpayers, and by the natural environment. Somehow I think I skipped a slide here. Yeah, this is the first conclusion. First conclusion, and they put this right up front. This was number 1. It says, dams have made an important and significant contribution to human development, and the benefits derived from them have been considerable. There's been a lack of equity in the distribution of benefits, and this has called into question the value of many dams in meeting water and energy development needs when compared with alternatives. By bringing to the table, and these were really suggestions now, but they were conclusions, but by bringing to the table all those whose rights are involved and who bear the risks associated with different options for water and energy resources development, the conditions for a positive resolution of competing interests and conflicts are created. That sounds very easy. In practice, I'm afraid it's far from easy. And negotiating outcomes will greatly improve the development effectiveness of water and energy projects by eliminating unfavorable projects at an early stage, and by offering as a choice only those options that key stakeholders agree represent the best ones to meet the needs in question. Again, a very honorable intention, certainly. The World Commission on Dams report, final report, and I have a copy here. I can't loan it to you because it doesn't belong to me, but it is very interesting. If the library doesn't have one, the library ought to get one, I think.
We have two.
Okay. It's worth looking at. In my estimation, the report is quite biased. It was intended not to be biased in any way. There's in full intention to try to appoint commissioners with a range of interests But it's clear that they didn't escape a bias against dams. They, in many cases, will discuss the benefits of a dam. For example, Grand Coulee, with enormous financial and economic benefits to the Northwest, have been enormously important in developing key industries of aluminum and things. Just a few sentences about that, but then several paragraphs about the negative effects of Grand Coulee Dam. Grand Coulee Dam was the first one built on the Columbia River, and so it cut off the salmon, which used to spawn almost 1,000 miles further upstream. Interestingly enough, you go back and look at that, you find that they had fish biologists look at this study, look at the dam site, and decide what to do, and they recommended not trying to build fish ladders. And that, now, today, I doubt that you could find any honest fish biologist who would come to that same conclusion. But the thought was that that was not an important issue, that generating electricity and providing water for irrigation was far more important, and that any loss of salmon as a result of that could be made up by building fish hatcheries, and everybody would be deliriously happy after that. And there are many cases, many items along through this report where that same sort of bias seems to be there. There's always a little bit of a negative dig there. However, I think the suggestions that as to far as planning and organizing people to review these projects who actually represent the stakeholders is vital. And that I was very interested in that because I really didn't know how much of that had been done. I'd never worked on a government project. And a couple of years ago, my wife and I were up in the very northwest corner of Montana on the Kootenai River, where Libby Dam is built. Libby Dam is a high concrete gravity dam built primarily for power, but also flood control and conservation storage. And while we were there, I just happened to meet a bunch of people who had formed an organization of former owners of land that had now been displaced by the reservoir. And it was interesting to talk to these people because when the project had to go ahead and had funding to go ahead, the people who owned land within the reservoir had no say in this at all. One day, some guy would knock on that door of the ranch house and tell you that I've got a check here for your land. You've got until year after next sometime to move out. And there was no negotiation. That was it. You bought it. The land was condemned. This is a public project, a public entity doing it, and under the law they could do that. It took quite a while. That dam was finished in 1968, but 4 years ago this organization began to fight it, and as a result they finally got the Corps of Engineers and Bonneville Power to agree that everybody or family members of the people who did own land in the reservoir at the time the dam was built should share in the benefits of that reservoir directly. And that's energy. And so now they get an annual payment from electricity revenues from that dam. And they don't go blow it on cars and parties. They have actually bought a couple of hydro projects up in Canada and created a foundation, and the foundation is providing scholarships for youth other people who want to go to school and study. So they're looking at handling this in a wise way and using that resource in a way that would benefit everybody who was affected well. And I think that's the worst problem that has occurred, particularly in foreign countries. If you look at the projects in Africa, rarely did the people who were displaced ever receive any benefit whatsoever from the project. The Aswan Dam, High Aswan Dam, is a fairly classic example. There were a fairly large number of Namibians, I don't remember, several thousands living in the upper areas of that reservoir who were displaced and moved back into Sudan and received absolutely no benefits whatsoever from the project. So I think this has been the biggest source of friction through it. Whether the World Commission on Dams work can provide a way to mitigate some of those problems, whether it can change the way in which projects are planned and constructed, still remains to be seen. In the United States, things have turned pretty strongly. We have in the United States about I think 13,000 dams. In the state of California, we have 1,315, I believe, or 16, depending on how you count them. The pace of dam building since about 1980 has been very, very slow. But nevertheless, in the United States, last year there were still some 36 dams under construction. Here in California, within the past 3 or 4 years, we've had several major dams completed. Los Vaqueros out here that augments the water supply for Contra Costa County, a very strongly needed facility because in drought years, those of you, if any of you live out there, know the water got pretty salty in Contra Costa Water District. So now with Los Vaqueros, it's an off-channel reservoir. They pump directly from the river in times when a great deal of fresh water is available. They fill the reservoir, and then when the flow in the river is low and the salt wedge gets far up, then they can supplement the water with releases of high-quality water from Los Vaqueros. 2 other off-stream reservoirs have been built, or one is being built and the other one is finished in Southern California. East Side Reservoir, built by Metropolitan Water District, a very large off-stream reservoir. It'll be filled with State Water Project water and water from the Colorado River when that's available. Olivenheim Reservoir is under construction now for the City of San Diego County Water Authority. Same function again, it's off-channel. It'll be filled by pumping State Water Project water into it in times of surplus and then using it in times of emergency. Very, very expensive if you consider how much the water actually costs that comes out of that. They don't give you those numbers. It's kind of hard to do because of the way those projects are operated. It's hard to decide what the real yield of them will be. There aren't very many dams, if any, that are being constructed on mainstream channels currently. Most of the cases are new dams that are replacing old dams that have been in trouble. Several back in Pennsylvania built in recent years that way that have replaced old dams. We don't have many sites left in this country for major storage projects on mainstreams. So that probably will not ever become a very big effort in the near future. I am somewhat biased, I know, in my opinion of the importance of dams and the benefits that they provide. I've had a career that I've enjoyed a great deal, and what has it done? It's given me a lot of first-class travel opportunities, and this is one that I had. So thank you very much. With that, I'll just quit here, and if you have questions, I'll try to answer them.
We have ample time for questions.
What's the technology of sediment control and what's used in the Three Gorges?
Three Gorges is strictly a sluicing process. They They have 26 large low-level outlets that are open during flood season when heavy sediment loads are coming down, and they pass that through. The reservoir will actually be pulled down something like 20 or 30 meters. It's more than that. It's about 50 meters. Be pulled down about 50 meters during flood season, and those low-level outlets will be opened, as many of them as necessary, to keep the reservoir stable at that level. And that passes a heavy sediment load downstream. Now they have another dam downstream, Yangtze Dam, which has been there since about 1984. It has not had sediment problems. They have the same design at Yangtze Dam with the large, I think there's 28 large low-level outlets there that operated the same way. There are sediment deposits in the reservoir above Yangtze Dam, but they're not drastic. They don't create navigation problems. They haven't seriously reduced the storage. And as a result of operating that dam since about 1985, they feel that they know how to operate Three Gorges Dam as well. And they don't feel that they will have an accretion of sediment that is a serious concern. They'll have some, there's no question about that. They have studied that thing in a number of different ways. They've modeled it analytically. They've modeled it with a half a dozen different hydraulic models using coal dust in some and sawdust in others and plastic beads in a third one. They've done a great deal of study on how to handle the sediment, because that is certainly a major issue. Yes?
Given the dams do have a lifespan, what do you anticipate as the problems that future generations are going to have to deal with? And how we might solve it?
Sediment is certainly oh, I'm sorry. What the question was, what do I think the problems are going to be that future generations have to handle in the lifespans of dams? One of the major problems is going to be sediment. A lot of dams that were figured to fill up in about 100 years with sediment. At the time those predictions were made, they probably weren't very good, but nevertheless they're real, and sediment is going to be a significant problem. It's a very difficult problem to handle once it's in the reservoir. The Riverside County Flood Control District has 3 dams on San Gabriel River down in the Los Angeles area. Morris Dam, San Gabriel Dam, and the third one whose name escapes me. They are the only organization I know of in the world that has actually cleaned the reservoir out. Those are flood control dams, and because of the tremendous value of downstream property, they can actually justify going in and cleaning them out, and they clean them out by just draining the reservoir, and then going in with earth moving equipment and moving it out. But they're in serious trouble because they can't get land from the Forest Service anymore to put the sediment in, and those dams really don't have any serious environmental problems with the sediment, but in a lot of places you have heavy metals and PCBs and other things to worry about. So there's a big issue as to how to handle that. The maintenance issues, as far as the structures themselves go, are probably not a problem. In many cases, dams are going to have to be rebuilt. Concrete dams built back in the 30s and early 40s often had problems of alkali reaction, and the dams have cracked and are becoming a maintenance concern. They will probably have to be rebuilt. In most cases, they probably will build a new dam downstream and tear down what they need. The design will have to agree with whatever the situation is there. Anything else? Yes, Bob?
What did they do with the sediment that they took out of those 3 dams?
Yeah, what did Riverside County do with the sediment they took out of these dams? They took it out with earth-moving equipment, and they were able to get land from the Forest Service to actually stockpile it. They filled up a couple of large ravines with it. They looked at the possibility of mining it commercially. They had hoped that maybe it would be valuable enough that they could take it downstream in a couple of the old gravel pits down there and dump it in and sell it to concrete manufacturing plants. Nobody really wanted to do that. It would have cost more than they could get their gravel for as it was. So they're just filling up a couple of ravines along the river. Yes?
What would be the solution to the sediment and something that the Tarbella River, which is filling up and it's a much bigger dam and it's,
Could you repeat it? I'm sorry.
in the Tarbella Dam that you showed?
Yes.
What would be a solution to the sediment problem there?
It's a terrible problem. The foundation for the dam is not good. It's a very deep alluvium, and in order to build a dam there, they built a very long apron upstream and to make a long percolation path so that they wouldn't get piping through there. But it's a very difficult situation. At this point, nobody has come up with a decent answer as to what they could do. Raising the dam is very difficult, maybe impossible, but certainly very difficult. I'm sorry, I didn't repeat the question. What can they do to Tarbella Dam because of this serious sediment problem? The reservoir is filling up rapidly. Say that the jury is still out on that. Yes.
Problems, especially in hydroelectric generation of methyl mercury that is exposed. When you operate in the reservoir, you get methyl mercury, and like for example, some of the deals structured by utilities like PG&E involve a sale to the public and then a repurchase, which leaves the environmental liability with the public and the benefits with the private dam operator. And I was just wondering what the credibility is for that kind of problem solving in the United States.
I'm sorry, I didn't follow your first part of your question.
Methyl mercury and hydroelectric dams.
Right.
Well, PG&E has a record of buying and then selling and then buying back. Okay, so that the environmental liability stays with the public and the benefits go to the private. And I'm just wondering how physical solutions to some of these problems can have any credibility at all when that kind of transaction is done.
Question was, when you've got a utility company that is selling their property and then buying it back or selling it again, and the ownership begins to get confused there as to who is responsible for cleanup if you've got a serious pollution problem.
It's not confused at all. It's blatantly transferred to the public.
I think probably the courts will ultimately come to grip with that. I don't think anybody else will, but it's going to, the person who caused the pollution is probably going to have to clean it up, but it's not clear how that's going to be done yet. I wish I could tell you, but I really don't know. Yes?
Could you talk a little bit on what dam design, what future dam designs might look like? Like optional reservoirs, mills, and kind of just the whole sedimentation problem. Are there other options out there?
What future dam design might look like, particularly related to sediment problems and other things? Wow. The status of dam design in terms of just a basic dam hasn't really changed a whole lot in probably at least 50 years. We do a lot better job of it now because we can analyze things a lot better with finite element methods and other things, so we're a little more confident. However, the standards are much higher now. I think as far as sediment problems go, the only real solution to being able to extend the life of a reservoir subject to large sediment inflows is to build in sluicing capability. The dam that I showed you, Cowlitz Falls Dam, the hydro dam where you couldn't see the power plant, is that way. On the right-hand side of that reservoir, of that dam, there are two fairly large outlet tunnels that lay right in the bottom of the river. It's a gravel bed river, but during flood season it brings a lot of small gravel down the river. When we build it, we build a cofferdam, upstream cofferdam, in order to do the construction. We left that cofferdam in place. It angles across the river, and then the two low-level outlet works come directly under the dam from the end of that cofferdam, so that when the flood season occurs, the reservoir can be pulled down, you increase the velocities through the reservoir, and then at the dam, the cofferdam tends to deflect the gravel into those low-level outlets and flush it past. And I think that sort of design is probably what is going to be required in many more cases now, and this sort of operation will need to be studied in much more detail than it has in the past.
But that's going to be for smaller dams, right? You can't do that for large dams.
Well, they're doing it in Three Gorges. They've done it on Yangtze Dam. Both of those are large dams. They're more than 300 feet high and large reservoirs, and it has worked successfully on Three Gorges Dam, on Yangtze Dam at this point. I think if it's handled right, the question is, I'm sorry, I didn't repeat the question again. She asked that the sluicing operation I described for Cowlitz Falls is okay for small dams. What do you do for large dams? And the question on large dam is how much drawdown do you need in order to get sufficient velocity through the reservoir to carry enough sediment out to make a difference. What it probably will mean is that operation needs to be done much more carefully, and you need much more data to do it. And a major dam like that should never be built again without very good upstream data on rainfall and stream flow, and to provide for real-time operation in order that you can finally close the gates and capture enough runoff to make the project meet its beneficial predictions as well. Yes?
You saw in the past century a huge amount of dam construction. Do you see dam removal being something become more common in the next century?
As I heard it, the question said, you asked about dam removal, and did you say?
Is this to become more common in the next century? And if so, are major dams going to become targets?
I'm sure you've all heard about the argument that the three of the dams on the lower Snake River ought to be torn out. There's Lower Granite and Upper Monumental and Ice Harbor. They're big concrete and earth-filled dams. To date, no major dams have been torn down. There have been several small dams that have been pulled out. There's one up in a couple up near Chico and Butte Creek that were torn down a year or so ago. There have been several back in the East Coast in Massachusetts. They were torn down in order to allow anadromous fish to move upstream. The scenario as far as tearing down the dams on the Snake River is far from clear at this point. Tremendous benefits accrue as a result of electrical energy and flood control for those three dams. I personally don't think the fisheries people really know what will happen if they tear those dams out. You still have all of the dams on the Columbia River for the fish to get through. Back in about 1981, the U.S. Fish and Wildlife Service and the National Marine Fisheries Service were convinced that the most serious element in mortality to the migrating salmon was the length of time it takes them to get through the dams and down to the ocean. For quite a number of years, they tried to trap fingerlings coming downstream at lower granite, put them in barges, and take them downstream and put them back in the river below Bonneville Dam, the last dam on the Columbia. In spite of that, runs going back up the Snake River have been getting smaller and smaller, to the point, I think, 5 years ago, I think there were only 20 sockeye salmon that went upstream past lower granite. However, at the same time, the steelhead trout were flourishing. They got bigger runs of steelhead trout on the salmon river now than they had in history. And I can't explain, why do the steelhead runs thrive there and the salmon runs don't, and they're handled the same way. You can't distinguish between them in the fingerling stage. I really don't think anybody can safely predict whether taking those dams out would make a significant difference in the salmon runs or not. There are people on both sides of that fence, and I certainly don't know enough to pick a side to be on. It's a tremendously expensive thing to do, to tear those dams down, and there would be large amounts of sediment go downstream. What the environmental effects of that would be, I don't know. Yes?
What's the feasibility of retrofitting some of these dams? What's the feasibility of retrofitting some of these dams with sluice gates and getting that sediment moving downstream?
Feasibility of what again?
Retrofitting?
Retrofitting. You can do anything with money if you can do that. I was over in Sudan last year on a dam on the Blue Nile, Rosiri's Dam, very, very important dam to the Sudanese. It provides irrigation water for a lot of acres there, and people are starving over there. They don't have enough water. The dam is silting up a good deal faster than they had anticipated. It's causing physical problems in the outlet works, erosion. We're looking at that to see whether there's a way to improve it. It's got 4 low-level outlet works, and they're pretty big. Whether something else can be done to improve that or not, I'm not sure. There are certainly, if you've got the money, you can do that, and if you can demonstrate that it's worthwhile doing, I suspect it will be done, particularly where dams where there's obvious benefit to them. Benefits that would be real benefits in terms of energy production, in terms of maybe some downstream, in-stream flow enhancement as well. It's very expensive to do on an existing dam. Concrete dam, not so bad. You can drill holes through it and probably put them in without seriously affecting the integrity of the dam. Earth dam, rock-fill dam, much more difficult situation to do. You might be able to do it, by going around through the abutments with a tunnel, but that causes problems in itself. I don't know. That's not something I've thought very much about. Yes.
2 questions. Just going one would be the cost benefit of the dam. When you're financing a dam, do you ever look at the lifespan to include in that benefit, cost benefit analysis, to include the cost of taking it out? And the other question would be, what do you think the reason is that so many dams haven't realized their benefits they propose? Is that just a lack of foresight or planning?
The question is, should you include the cost of taking a dam out when you estimate its cost in the beginning and make your predictions as to what cost and benefits are going to be? And then secondly, ask why haven't dams met their predicted production benefits? In the first case, probably has to be done now. You at least should be thinking about what that has to be done. However, most dams last a long, long time. There are lots of dams in the United States that are 100 years old now and still functioning fine. There are others that aren't near that old that are filling with sediment and not functioning very well. It's more a matter of careful design and careful studies ahead of time to make a more reasonable estimate of what the lifespan of that dam is going to be. But certainly that ought to be part of the plan as to what might ultimately happen to that dam. However, political directions tend to be about 4 years in length, and by the time a dam reaches the end of its lifespan, you have no idea what the political element will be at that point. The other part was why haven't dams met the goal? I think for the most part, the most serious ones that have failed to meet goals have been irrigation projects. And this has usually been a matter of over-optimism, I believe, in what could have been produced in those croplands, what it was going to cost to actually develop the irrigated land. In many cases, they never did reach their ultimate goal in terms of the number of acres that were to be developed. Sometimes because the land just wasn't good enough to be developed. Other times because they had drainage problems and salt began to be a serious problem to them, and they didn't have money to build the drainage. Most of the time, I think it's been political difficulties in developing countries where graft has taken an awful lot of the money out of the benefits of the job. Oftentimes, graft took an awful lot of money out of the front end, and the project didn't get built to the standards that it was intended to. I don't know how you correct those. You just hope that these countries can get their act together and that organizations like the World Bank have better control on the money that they loan than they have had in the past. Yeah.
Yeah, my question is, what do you think, or your prediction about these large dams when their lifespan run out and they're beginning to degrade? Are they able to operate it still, or are they going to drain these and shut them down and rebuild new dams, or leave them?
Well, both. The question was, how about dams, large dams, and their lifespan is running out? What do you do at that point? Do you rebuild them, or do you build a new dam? The old Army response used to be, it depends on the situation and the terrain. A lot of dams can just be rehabilitated and made a bit stronger. There's a couple of dams in California that became worrisome because of earthquake loadings, and they built roller compacted concrete berms on the downstream side to strengthen them. So there's a lot of rehabilitation measures that you can do to improve a dam's condition. If it gets to be too bad, it has to be rebuilt. And back in the about 1978, 79, I guess, American Falls Dam on the Snake River in Idaho. It was built very early, back in the early 30s, but by irrigation district there, and actually the Bureau of Reclamation designed and built it for them. But it had very serious concrete aggregate problems, and the dam was cracking very, very badly and became very much a safety concern. So a new concrete dam was built downstream from the old one. The old one continued to operate all the time that the new one was being built. And finally, the old one was built and the irrigation season was over. They pulled the reservoir down and blasted off as much out of the top of the old dam as they needed to be able to get good operation for the new dam. What you do is going to depend on the best and most economic way to do it. Say many dams in this country are approaching 100 years of age and still operating. A lot of them are over 50 years of age and operating just fine. They take maintenance. There are regulatory authorities in each state, dam safety commissions, that inspect dams regularly and require owners to keep them safe. The Federal Energy Regulatory Commission in Washington, D.C. requires a full inspection of every dam that generates electricity every 5 years with a written report by an independent consultant, and forces those companies to spend money to upgrade the dam, keep it safe.
I was just going to ask something regarding safety concerns. Is terrorism a threat to dams? Are they being
the question was, is terrorism a concern with dams? I'm sure it could be. It's not easy to knock out a dam. You can do it. It's been tried a lot of times. Back during World War II, the Allies spent a lot of time bombing dams in Germany and did actually get one to fail finally and cause a lot of damage downstream. In Yugoslavia, when the Serbs left Bosnia, they placed an enormous explosive charge in the bottom of a large concrete gravity dam there. It caused a whole lot of damage, but the dam didn't fail. In fact, it hardly leaks, but it's not easy to do that. The terrorism would take an enormous amount of explosives in most cases to do much. I'm sure somebody's looking at that, but I haven't been involved in it. Linda?
All right. I've read about some alternative proposals for, let's say, Hetch Hetchy, taking down Hetch Hetchy Dam and maybe building some smaller dams down the way, or Hoover Dam. So have you heard about those proposals, and what do you think about those?
Question was, have I heard of proposals for taking out Hetch Hetchy Dam and Hoover Dam and rebuilding with smaller dams? I've heard some people talk about such things, but I don't think it's very serious talk. It would be enormously expensive to begin with. I'm sure that a lot of people would like to see Hetch Hetchy taken out. Heaven only knows how long it would take for that canyon to recover to a point where it was as beautiful as the Yosemite Valley, but maybe it's worth doing. It depends, again, on what your values are. Hoover Dam, there's an awful lot of water stored behind Hoover Dam and Flaming Gorge Dam on Glen Canyon Dam on the Colorado River. That water is an enormous benefit to Arizona, Nevada, and California. I doubt that you would ever get the political strength to ever take either one of those dams out, and you certainly couldn't replace them with smaller structures. It just probably just couldn't be done. Yeah.
I was wondering about the impact of the World Commission on Dams study, if it had any effect. Did it make a difference in actually stopping dams?
Question was, what impact has the World Commission on Dams study had? Has it had an impact in stopping dams? I'm sure it's had an impact. It's gotten a lot of attention. They are in the process now of establishing a group who will be charged with going around the world and getting the information that's in that report out to the various countries and various entities that are involved in this. Hopefully they won't have a major axe to grind and going in one direction or another. I hope they're impartial. That hasn't been done yet. They're starting. At this point, the results certainly have been disseminated widely among the dam community. The people who design and build and own dams, they know about this and have heard about it a great deal. As far as going beyond that, I'm not sure. The World Bank certainly, they spent a good deal of money in getting this report together. I'm sure that they will use it in whatever way they can. I hope that it doesn't come out and be promoted as biased as it sounds in places. I feel like they really did not do justice to the benefits of dams. Certainly there have been bad mistakes with dams. I personally feel that most of them have been a situation where the political climate just didn't allow or didn't require proper planning and treatment of the people who were to be impacted. I believe myself very strongly that people displaced should share in the benefits, should share directly in the benefits. That hasn't been the case in a lot of cases.
I was just wondering what role you envision consultants playing in this. I mean, traditionally engineering firms are brought in to do a job, and it certainly might not be in, say, Bechtel's or URS's best interest to come in and say, well, did you ask the right people before we build this dam? But on the other hand, consultants have a lot of power to affect their clients. So I'm just curious, but maybe you could just give an example of what Bechtel's doing or what they might do.
Question is, what role will consultants play with this new approach to planning and design for dams? The Bechtel's response is get out of the business. They don't do much engineering or construction anymore, and it's project management almost totally. My guess is that it won't change the consultant's role very much, except it'll probably bring more people, different people into it. It'll bring planners into it earlier that will have more of an environmental bent and more of an economic view of things, and that it will improve the planning process. And the World Bank and International Monetary Fund all require an owner building a major dam to have an independent consulting board. I'm sure that the World Bank will not improve an independent consulting board anymore unless it has some people on it besides geotechs and concrete and hydraulic engineers. They're going to have boards that span a much wider part. And probably what it will mean is that there will be consulting boards, separate consulting boards. Early in the stages, there will probably be a consulting board that is more of a planning entity that looks at all of these issues. Once that's done, there will be another board that develops conceptual designs and finally feasibility and final designs. And the final design probably won't contain these environmental people or political people anymore. It'll be back in engineering's realm. Yes?
Can you tell us about fish kill from water turbines?
That's an interesting question. What about fish kills and water turbines? A very interesting question. So I mentioned earlier that back in about 1980, something like that, the National Marine Fisheries Service and the Fish and Wildlife Service were convinced that the length of time it took to fish to reach the ocean was the most serious cause of mortality. Turbines, second most serious was predators, seagulls and squaw, in the Columbia River, seagulls and squawfish sitting downstream from the dam picking up stunned fingerlings as they came through the turbines. Somewhere along the line, somebody lost sight of that, I think, and money that's been spent, and there have been probably $200 or $300, maybe $400 million spent trying to screen fingerlings out of the turbines. And it always seemed to me like this is a strange way to approach this problem, is to pick the least, the element of least mortality to go after and try to eliminate it. What they're doing on the Columbia now is trying to screen them out of the turbines and put them right back in the river downstream. Now they're trying to find places downstream that will be somewhat predator-free. But my guess is that predators probably are smarter than that. The predators will probably go where the fish are. And, yeah. But there is a major research project underway by the Department of Energy to develop a fish-friendly turbine. I think there's been somewhere in the neighborhood of $35 million devoted to that so far. Alden Research Laboratory back in Holden, Massachusetts, as one part of that, where they're developing a totally new runner. The runner looks more like a corkscrew. The idea being that there won't be any, where you have a single layer of blades on a turbine, you have a very drastic pressure change from one side of the blade to the other. And it's felt that this is a major source of damage to the fish. Well, Alden's idea is that if you don't have that, if that's distributed throughout this long corkscrew runner, that they won't have the same mortality. They're just this year going to go into mortality tests with that using rainbow trout. Voith had another piece of that action. Their approach was to better design the turbines that they have, getting smaller clearances, getting blades that are more designed in a more friendly way, and I'm not sure what that is, but anyway, they're trying to make their existing turbines or their existing designs more fish friendly. What'll happen out of that, I don't know. It's there's certainly a lot of interest in doing that. As I say, it seems strange to me because that's the least cause of mortality among the fish. But that's the one thing, I guess, that you can address. You can't change the length of time they go downstream unless you barge them. And I personally think that hasn't been looked at anywhere near as seriously as it has. They've done it. They've tried barging them, but the fish returning are still going down. But nobody knows for sure whether it's as a result of the barging or whether it's a result of fishing or disease or something else out in the ocean. For quite a while, there's a big fight going on. The fishermen said it was the dams. The dams are causing all the problem. The dam said, oh no, it's not the dams, it's the doggone loggers. All the sand getting into the spawning beds is ruining the spawning beds, and they can't do it. The loggers said, oh no, it's not us, it's the Indians. They can fish and take all the fish they want, and they're killing them. Well, the Indians haven't taken any more now than they used to take years ago, and their records are pretty clear. But this is where it is. It goes around and around in a circle. Nobody's really accepting the blame for it.
We have time for one last question. If not, I should like to thank you for a very, very educational talk, a good combination of engineering and human beings. Thank you.